It's 30 minutes video around.
Hello, I am Shutaro Takeda, Chief Strategist and co-founder of Kyoto Fusioneering. Today, I'm going to introduce to you the latest project from Kyoto Fusioneering, unique integrated testing facility for fusion power generation, Unity. So let me start the presentation.
We are Kyoto Fusioneering, Japan's first fusion startup founded in 2019, spinning out of Kyoto University, and we accelerate the development of high-performance, commercially viable fusion plant components associated with the power generation cycle and fuel cycle. We have locations around Japan, as well as one location in the United Kingdom, and we are planning to open another location in the United States by the end of 2022. And we specialize in fusion plant technologies, and we are already operating cutting-edge in-house R&D facilities that develop gyrotrons for plasma heating, tritium fuel cycle technologies including pumping, advanced tritium breeding blankets focused on lithium lead, lithium, and FLIVE, as well as liquid metal and molten salt technologies. And by pursuing fusion engineering technologies, we have realized that nobody has tested a blanket for a fusion reactor, and problems around lithium burnup, low conversion efficiency, high beryllium usage making solid blankets potentially non-commercially viable. And nobody has demonstrated heat extraction from a blanket. This is not even planned for ITER, so this is urgently needed for the private sector and upcoming demo programs. Material challenges for fusion environment with liquid metal or molten salt are significant and should not be overlooked. And nobody has demonstrated high temperature power cycle from liquid metal or molten salt. And high temperature around 1000 degrees Celsius heat extraction from liquid metal or molten salt are not demonstrated. And on top of that, tritium permeation within the power cycle should not be underestimated. So the conclusion from this analysis is that beyond lab-scale integrated power cycle R&D is urgently needed as the next step for the fusion industry. On that, introducing Unity, Kyoto Fusioneering's uniquely integrated testing facility for fusion power cycle. This Unity facility is comprised of gyrotron testing section and simulated fusion power core, which is a blanket and diverter integrated testing unit, a 1000 degrees Celsius heat extraction demonstration unit, tritium pumping testing section, fusion fuel cycle demonstration unit, multi-purpose testing section for heat exchange and tritium extractions, and connecting all that dual high temperature coolant loop lithium lead plus molten salt, driven by electromagnetic pumps. And we will also have energy conversion demonstration section that will demonstrate electricity generation. So this is Unity, Kyoto Fusioneering next step large investment as an in-house integrated testing section. So this Unity project has 4 stages towards its completion. The first stage this year is the demonstration of the lithium lead loop. So by the end of 2022 fiscal year, which is to March 2023, we will complete the lithium lead loop, and we will study and verify the materials and components required for a fusion plant. And in the next stage in 2023, we will start the blanket testing campaign. We will demonstrate the advanced blanket performance in experiment plus simulation. In the next year, at stage 3 in 2024, we will start the power cycle demonstration, which is the demonstration of electricity generation from blanket, which will be the world first. And finally, in 2025, at stage 4, we will integrate diverter and gyrotron testing section. And this, by the integration of diverter and gyrotron, we will demonstrate all the core Kyoto Fusioneering products for the fusion industry, all in one facility. So this Unities project is comprising of 7 separate facilities. Let me dive into one by one. The first one is a simulated fusion power core, which is the diverter and blanket integrated testing section. So Unity's blanket testing section features the following very cutting-edge features. The first one is multiple blanket testing capabilities. What it means is that it has experimental capability with multiple coolants, including lithium lead, lithium, fluid, and water. And this will allow a wide range of blanket configuration to be tested in this single section. We will also have the capability to test in 4 Tesla magnetic field. This strong magnetic field with gradient will be able to measure MHD effect in blanket modules. And finally, we will have the capability to extract high temperature coolant up to 1000 degrees Celsius. And this simulation of a volumetric heating by external heating will enable us to test high efficiency lithium lead or molten salt blanket modules that can never be tested anywhere else. This blanket module testing unit will be able to complete it in a relatively short amount of time because Kyoto Fusioneering is already currently operating both FLIVE and lithium lead loop. So we will scale up these pre-existing loops to a full blanket testing loop. And by doing so, we can shorten the R&D time for the Unity section. Next, the extracted heat from the simulated power core will go into 1000 degrees Celsius heat extraction demonstration unit. The heat extraction section of Unity will demonstrate and test materials and components in a fusion-relevant environment up to 1000 degrees Celsius. And this loop will be the first of its kind R&D platform to study lithium lead or molten salt and the silicon carbide composite interactions. And in order to enable this high temperature heat extraction, high temperature heat exchange, we are developing novel 6-stick manufacturing method and the development at Kyoto Fusioneering with Kyoto University, as you are seeing below. Again, Kyoto Fusioneering has already had a collaboration with Kyoto University where we have demonstrated heat exchange between lithium lead and helium up to 900 degrees Celsius already. And this is why we have been able to shorten the R&D time for the Unity program. And on top of extracting heat, we will also extract hydrogen isotopes. Here, as an analog of tritium, the Unity will use deuterium, but we will demonstrate the deuterium and the hydrogen isotope extraction. And the R&D and demonstration of this hydrogen isotope recovery is key for designing a future power plants. And in Unity, we will demonstrate hydrogen recovery from the blanket for the 2 primary components, FLIVE and lithium lead. And we will also demonstrate the handling and storage capabilities for the hydrogen isotopes. R&D and demonstration of tritium handlings, including the pumps for treated gas, and assessment of deuterium and isotope separation technologies will all integrated into Unity to be demonstrated as a system. What it means is that the Unity will demonstrate the entire fusion fuel cycle. What enables this fuel cycle is the Kyoto Fusioneering's tritium pumps. What you're looking at is tritium roughing pumps, which we are already selling to our partners, which has high tritium capabilities, which can handle air, helium, oxygen, or hydrogen, which has no metal bellows, which enables continuous operation for the high concentration of tritium. And we are currently setting 3 specifications for this specific pump, which you are seeing here. So on top of heat extraction and hydrogen isotope extraction, this loop will have multi-purpose test bed for additional experiments. These additional experiments includes a corrosion testing for the 6 components, bifleave and lithium lead, which have already been carried out in preliminary experiments at Kyoto University. So we also conduct additional hydrogen isotope extraction or heat exchange experiment with this multipurpose testing section. And this multipurpose section is also open for our partner collaborators. And finally, by creating a secondary system, we will also demonstrate energy conversion. Unity will demonstrate electricity generation from blanket in 2024, which have never been demonstrated in the world. So this Unity facility will examine a number of potential electricity generation cycles, including Brayton cycle and Rankine cycle in fusion-relevant conditions. And this experiment will yield critical understanding of fusion plant systems and key parameters required for designing a fusion plant. And high temperature heat exchange and tritium permeation to the generation system should not be underestimated, so that this type of integrated testing is required before constructing a fusion power plant. The Unity will also demonstrate alternative applications of high-grade heat, and this includes hydrogen generation. And finally, in 2025, we will integrate the gyrotron testing section into Unity plant. So as reported, Kyoto Fusioneering has won a contract for the UKAEA's mass U upgrade for gyrotron. But we are planning further upgrade to our gyrotron section. And this upgrade testing will be conducted also at the Unity section by the end of 2025. And this will enable us to construct and test and demonstrate the entire fusion power cycle in just one facility. But most importantly, the Unity facility will be open for partner companies, and this is as an R&D collaboration platform. So the Unity is not a proprietary platform. It is an open platform that is available for all of our partner companies. Again, towards its completion, we will have 4 stages: demonstration of the lithium lead loop, start of the blanket testing campaign in 2023, start of the power cycle demonstration in 2024, and integration of diverter and testing section in 2025. By doing so, we will demonstrate the full fusion power system completed by 2025 for the first time. With international engineering partners, Kyoto Fusioneering seeks to become the world leading supplier of fusion plant components towards a new dawn of energy for humanity. Thank you very much for your attention, and we look forward to collaborating with you.